how can you generate an interference pattern with light that hasn't interacted with the object? The trick is to use a quantum property of light, a mechanism known as quantum entanglement. The scientists were able to use entangled photons to transfer information from a photon that interacted with the object to a photon that didn't. They did this by first generating entangled photon pairs using a nonlinear crystal, which parametrically downconverts the light. Basically, the nonlinear crystal converts a single photon with frequency x and makes two photons with frequency 2x, such that the energy is conserved. An ultraviolet laser shown in purple shoots a beam of photons into their nonlinear crystal, which produces a red and green beam. The red beam is selected off using a dichroic mirror, which reflects certain wavelengths while transmitting others. Then the beam is reflected back onto the camera. The purple beam is reflected at the end and then is also redirected onto the camera, acting as the reference laser. The green beam is reflected onto the object, where it interacts with the object, and the entanglement between the green and the red beams allows the information to be transferred between the two photons, so that while the green beam has seen the object, the red has not, and it is this beam that forms the hologram. With this setup, they were able to produce quantum holograms of several different objects. While these images may not be particularly impressive objects, they're an important calibration step to quantify how quantum holograms work and therefore find what applications they might be viable for using for, a necessary step before moving towards more complex structures. So why is this an interesting result? Well, any demonstration of new quantum mechanics is interesting, but there's more to this story, and this comes down to the wavelengths of the light that the nonlinear crystal can produce. As I mentioned earlier, the two photons don't have to have the same energy. And in fact, we can make this energy difference extremely large. And this is of particular importance to medical research. Holograms are actually already used in medical research, but there are problems with using this technique. The light can sometimes hurt us, or it can be absorbed rather than reflected, therefore ruining the image. And for applications where we want to image something that's actually inside of someone, this becomes even more prevalent as the wavelength of the light really matters on how far it can penetrate inside of our bodies. On the other side, the resolution of holograms is directly related to the wavelength of the light, with higher energy being better. So to get the best of both worlds, we want to have an entangled pair of photons, one which has an energy in the ultraviolet spectrum, or the other way down in the infrared. This way we can get the best resolution holograms while also being able to image inside of people. This being said, there's still a lot of work to go into this before we start to see real applications of this type of technology. But it's certainly an interesting experiment, and I'm sure it's going to spur on more research.